video deals with similar triangles and indirect measurement. The similar triangles we talked about on the last assignment. So that's nothing new, that's just setting up stuff. The indirect measurement, that's going to be the new part. And I'm also going to go back over those two theorems that I talked about a little bit last time and show you how to do those, because there's some of those problems on the worksheet. This is assignment 6. Assignment 7 is going to be a test over similar triangles and stuff that we've covered since the last test. So this is assignment 6. Assignment 7 is going to be a test on the worksheet that I sent out to you. I'm going to work most all the problems, or probably all the problems, out for you. What I'd like you to do is I'm probably going to put them on 2 separate videos. This is video 1 here. So some of them I'll work out on here to show you some of the problems, and then I'd like you to try the rest of the packet on your own, but then I'll send out video 2 also that'll have the answers on it, or have me working out the problems so you can see if you're doing them correctly. Now the key to this is, I know there'll be some of you who will just take my answers and write them down and send it back to me, and there's nothing I can do about that. But for you to understand it, you need to actually try to do them and not just use my answers. And also remember that assignment 7 is going to be a test over this stuff. So if you don't know how to do it, then you won't be able to do the problems on the test. So with similar triangles, just referring back to similar triangles, and actually similar polygons, doesn't have to be a triangle, it could be any polygon. 2 things to remember always: the corresponding angles have to be congruent. The corresponding sides are proportional. So the angles that match up are always exactly the same. The sides are proportional. So the sides either get bigger or smaller. The 2 theorems that we talked about, the first one is theorem dealing with perimeter. For perimeter, you just set up this proportion, and what this allows you to do is we could go through and we could find the length of each of these sides in this pentagon here, this 5-sided shape. We could find each of those by setting up 4 separate proportions and solving them, and then add them all up to find the perimeter. If we don't need each of those sides separately, if we just need the perimeter, then we could find the perimeter of this, which we don't know, by using this theorem. We can find the perimeter of this shape, the black shape here, by adding up all the sides. So that's the first thing I'm going to do, is I'm going to add up all the sides here and find this perimeter. 8 plus 12 is 20, plus 4 is 24, plus 7 is 31. And you could do this on your calculator. 14 plus 31 is 45. So the perimeter of that black shape is 45 units. What this theorem allows us to do is it says you're just going to compare a side in shape 1 to a side in shape 2, and that should equal the perimeter of shape 1 compared to the perimeter of shape 2. So it's just telling you how to set up the proportion. So on this one, I got to make sure that for the sides, I take 2 sides that match up. If I look at this black shape first, it looks like the 8 matches up to the 3 in the other shape. You got to make sure that you match them up correctly. So my first ratio is going to be 8 compares to 3, the same as. Now I'm going to use the perimeter. The perimeter of shape 1, which we know is 45, compares to the perimeter of shape 2, which we don't know. And I'm just going to use P as my variable, you could use x, y, whatever variable you want to use. I use p to remind me that it's dealing with perimeter. We cross multiply here, we get 8p equals, cross multiply this way, we get 135. Grab your calculator, you can divide. It's probably not going to come out all real nice and even, so we grab our calculator and we divide 135 by 8, and I end up with 16.875. So the perimeter of this shape is 16.875 units, whatever those units are. So that's the perimeter theorem, not a real difficult one. You're just setting up, putting in, you got the theorem right here, and you just put in a number here, number here, number here, number here, or variable wherever it happens to go, and that's going to allow you to do it. But this explains exactly what you need in the proportion. The next one is the area theorem. And I'm going to rewrite this. This is probably a better form here, just to make it look more like the other one. If I do a side from shape 1 compared to a side from shape 2. Now the difference in this one is that each one of these numbers you have to square it. So you have to square each one of those. And then that's going to compare to the area, or equal to the area of shape 1 and the area of shape 2. So every time we're just going to set that up. If we look at what we have down here, the formula for area of a triangle is area equals 1/2 times base times height. Well, if we're looking at this green one, we're trying to find the area of it. We don't have enough information to be able to find that area just by using this formula. So I can use this, if I know that these two triangles are similar, I can use this theorem to find that. And that's what I'm going to set up here. So I find a side in shape 1. Well, they give me the 10 here. So I'm going to say 10 matches up to the 3. And the thing I got to remember with this, and I forget this all the time, is you got to square each of those sides when you put them in there. And then you're going to do the area of the first shape compared to the area of the second. So the area of the first is 120. The area of the second, we don't know. First thing I'm going to do here is I'm going to square each one of these before I start cross multiplying or anything. 10 squared, then again, grab your calculator if you need it. 10 times 10 is 100. 3 squared is 9. And I got 120 over here, A here. Now we're going to cross multiply. I get 100A equals, you can grab your calculator, 9 times 120 equals 1080. Divide both sides by 100. You end up with just A on this side. On the other side, that 1080 divided by 100. You could probably do that in your head, or you can grab your calculator. You end up with 10.8. Always make sure that your answer makes sense. We're dealing with area, and we had centimeters here, so it should be centimeters squared because area is always in square units. And then make sure, if we're looking at this, you should realize that this area that you're coming up with should be smaller for the green triangle than the area for the blue triangle was, and it is quite a bit smaller. So those are those two theorems. Now we're going to move on to the different indirect measurement forms. And I'm going to give you 3 things to write down here And as we go through them, I'll show you pictures of them, but these are the 3 formulas to write down. There's 3 different indirect measurement methods. The first one's shadow method 1. And we'll draw a picture with this, and then I'll write down the stuff also. In the picture, it's just going to look something like this. You could have maybe a person, and that person, as long as the sun's shining, always casts a shadow. And then maybe we're trying to find the height of a building. This is my building. And that building's going to cast a shadow. And what we can set up here, the proportion we can set up, is always, and I'm going to write person in here and building, but it doesn't have to be a person in a building. It could be a tree, could be, it could be any other object. It doesn't have to be a person, could be a stick, a board, a table, whatever it is. But I'm going to write person and building. But for yours, it doesn't matter when you set up. So person, height, we're going to put that on top here, and we're going to compare it to the building height. And again, it doesn't have to be a building, it could be whatever. So sorry, I wrote that in the wrong spot. That's not where I want it. It could be there, but I want to make sure that we make it as easy as possible. So I'm going to put building height right here on the bottom. So person height compared to building height. And then what you're going to put on the other ratio, person shadow compared to the building shadow. Now all this is based off of similar triangles, and it doesn't even look like that we have triangles here, but what we could do is we could draw in this, we could draw in this, and what we're going to know every single time is that these 2 triangles that I have here are going to be similar to each other. And the reason they're going to be similar is because of angle. When the sun is shining down, and I'm only going to explain this once, when the sun is shining down on each of these things, well, the sun is hitting this person at the same angle that it's hitting this building. So that's one pair of angles that we know are congruent. And we're hoping that the building with the ground forms a right angle, and the person with the ground, if you're standing normal, should also form a right angle. So these 2 triangles are always going to be similar. I'm not going to ask you to prove that these are similar for this assignment. Just know that this always works out for this shadow method 1. That these 2 angles are always the same, these 2 angles are always the same. And all we're going to do is set up this proportion right here. We put in the parts that we know. Wherever we know something, we put it in. And then the part that we don't know is going to be our variable. So that's shadow method 1. The mirror method is set up like this. Use a mirror. And if we were in class right now, I'd get my mirror out and I'd show you how to do it a little bit, but since I can't really show you the mirror, this is what you're going to do. It's going to be a picture like a person lays a mirror on the ground in front of them, and they look in that mirror, and they can just see in the mirror there, they can just see the top of whatever it is they're trying to measure. Let's say they're trying to measure a tree over here. So this is my tree. Well, with this, we can measure, and and that should be at the bottom of the tree. My picture's not drawn very well. With this, we can measure how far the person is from the mirror. That's this distance. And we can measure how far the tree is from the mirror. And we can measure the person's height. And what we're looking for normally is the height of the tree. And with this, it's always, again, this is going to form a triangle when that person looks in there, top of the tree there, so you have this triangle. And that triangle is always going to be similar to that triangle. Let's see if I can't make a little better drawing here. So you got the person, and the mirror is in the middle here. We can measure the height of the person. We can measure the distance the person is from the mirror. We can measure the distance the person is from the tree. The thing we don't want to do is try to climb up the tree and measure how tall the tree actually is by dropping a tape measure down there. So we can do this, and this is why it's called indirect measurement, because we're measuring it, but we're not doing it directly. And that's going to set up, and I'm going to set it up as a proportion over here. Same idea. Person, height. And again, it doesn't have to be a person, doesn't have to be a tree. It's just what I'm using for this example. Compared to the tree height. Next one, distance, person, distance. And I'm going to write this out to make sure everybody understands it. From the mirror. Sorry, that's sort of ugly. And then we're going to compare that to the tree distance from the mirror. Distance. So every time you're just going to set up, you're going to put in the person's height here, the tree height here, distance from the mirror that the person is here, distance the tree is from the mirror there. One of them you're not going to know, one of them is going to be a variable. And again, what's happening here is we're using similar triangles. If we look right here, this person, their eyesight's going down into this mirror. They have a triangle. And that triangle, if they match up the top of that tree and the mirror right there, that triangle is always going to be similar to the tree's triangle. The reason it's always going to be similar is, again, should be a right angle here. Tree forms a right angle with the ground, and I know somebody will want to argue that not all trees form a right angle with the ground, but they do unless they're growing on a hillside, because all plants, can ask your science teacher, all plants try to go straight towards the sun, and that's the way the earth works. So if you got a tree that's leaning over, it's probably because it got blown by wind or something, and it will start trying to grow back up straight again. Then the other thing is this angle that the person's looking in the mirror at is the same angle as if there was a squirrel sitting up here in the very top of the tree, same angle as that squirrel's looking down at that mirror at. So by angle, these two triangles are always going to be similar. And again, all you're going to do, you're going to read the problems and stick the parts in there that you know, put in a variable for the part you don't know, solve the proportion. Third methods is shadow method 2. This one's a little harder, not really harder, just a little different. What you do with shadow method 2, if you have, and I use trees and buildings all the time, just because that's something that I can actually draw that maybe you can see what it is. So if I have a tree, and that tree has a shadow, and then I have a person, And that person, this time, instead of like the top one that we did up here, that person stands on the tree's shadow and lines up the end of their shadow with the end of the tree's shadow right there. Again, we have two triangles. Switching back to my normal color here. It'll let me. We have two triangles. We have the tree's triangle, and then we have the person's triangle. What you're going to have to do here, and what you have to be careful of with this one, is realize that the tree's triangle doesn't start at the person and go to the tree. It's this along with the person's shadow. That's the whole side of the tree's triangle. Sometimes you might only know what we might measure is the distance the person is from the tree. So if they tell you the person's 30 feet from the tree and that their shadow is 8 feet long, then this side in the tree's triangle is going to be those two added together, which is 38 feet. So you have to be able to separate them off. You might even want to do that. You might want to separate off the tree's triangle and the person's triangle, and then label the parts that you know to make it look more like this first one, because it's a little easier. But as far as our proportion goes, our proportion is is exactly the same as this first one. You take the person's height, and you're going to compare it to the tree's height, or again, it doesn't have to be a tree, it could be whatever. And then over here, you're going to have the person's shadow, length of the person's shadow compared to the tree's shadow. And again, be careful on the tree's shadow. Don't think that it's like in this example I gave, don't think it's just the 30. The tree shadow is that whole length. Sometimes they'll tell you the whole length, sometimes they'll only tell you this part, sometimes they'll tell you the distance here and the length of the whole tree shadow, and you'll have to find the person's shadow. Just depends on the problem. But again, in this picture, we have two triangles. If I'm looking at those triangles, we know that the person here, as long as they're standing straight up and down, and the tree here is, if it's standing straight up and down, they're parallel to each other. So that tells us that this angle and this angle are corresponding angles, and they have to be congruent. And then we also know that both triangles, the tree's triangle and the person's triangle, share this angle. So by the reflexive property, it has to be congruent. That means the two triangles have to be similar by angle. All right, I'm going to do several off the worksheet. And then again, I'm going to stop this video and I'll let you try some of the rest of them off the worksheet. And then there'll be a second video that explains all of the rest of them. So use it wisely. And I'm sorry that this worksheet's so long. It's not that it's so many problems, it's only got 35 problems on it, but it's got several pages because only so many can fit on each page when you're dealing with drawing these pictures and everything. Like the first page, it has 3 problems on it. Number one on the first page. Says a 4-meter flagpole casts a 6-meter shadow. So we got a flagpole here, and we know it's 4 meters tall, and you're going to have to draw these each time, and it casts a 6-meter shadow. At the same time, a nearby building cast a 24-meter shadow. So we got some building over here. My pictures are not drawn to scale. You don't have to draw them to scale, just draw them so that you can understand it. And it casts a shadow that's 24 meters. And we want to know how tall is the building. So how tall the building is, that's right here. That's going to be our variable. So I'm going to put an X there. Again, you're just going to match it up in a proportion. You're going to set up the height of the flagpole, which is 4, matches to the height of the building, which is X. And then the flagpole shadow is 6, matches up to the building shadow, which is 24. Ignore that stray mark going up through there. We're going to cross multiply. Grab your calculator if you need to. 4 times 24 is 96. And if we cross multiply the other way, 6 times x is 6x. Then all we're going to do is solve, divide by 6. These cancel out. You end up with x. 96 divided by 6 equals 16. So our answer to our problem, we look back over here, make sure it makes sense. The building is 16 meters tall. Number 2, a 5-foot tall Madeline casts an 84-inch shadow. You got to be careful with this one. And there's several on here that you have to be careful with. You have to know how to transfer stuff in from feet, inches, so on and so on. Then how tall is her friend if at the same time his shadow is 1 foot shorter than hers? So we got Madeline here, cast a shadow. Got a friend over here, cast a shadow. We know that Madeline is 5 feet tall, so I'm going to put 5 feet right here. And she's got an 84-inch shadow. And it says that her friend cast, we don't know how tall her friend is, so that's going to be our variable. But the shadow that her friend cast is 1 foot shorter than Madeline's. Well, 1 foot is 12 inches, so we can do 84 minus 12, and that gives us 72. So the friend's shadow is 72 inches. You can set this up with feet and inches in it, but if that's confusing to you, as long as the feet are in one ratio and the inches are in a separate ratio, they can't be in the same ratio. Well, they can actually, but they shouldn't be in the same ratio with each other. But if it helps you, then just change this feet into inches. And all we do to do that is take 12 times 5, grab your calculator if you need to, that comes out to be 60. So Madeline is 60 inches tall. When we go to set up our proportion, take Madeline's height, which is 60. Friend's height is X. So we compare those two. Madeline's shadow, which is 84. Her friend's shadow, which is 72. Grab your calculator. We cross multiply 60 times 72. Bad thing with changing all this into inches is that it gives us these big numbers. Cross multiply the other way. 84 times X. Divide both sides by 84. So we take I wrote this down wrong, 4,320. That's what you should have gotten there. I wrote it backwards. And we divide that by 84. And I end up with 51.43 or something close to that. And that's in inches. That's how tall our friend is in inches. If we wanted to change that into feet, then we would just divide this by 12 If you just wrote down 51.4 inches, that's not a real good answer because inches don't have decimals, they deal with fractions, but I would probably accept that as an answer. If you wanted to change it to make it a little better answer, what you could do is you could, we could have not changed this and it might have gave us a little better answer. Here we could divide by 12. So if we take that and we divide by 12, we come up with 4.29. That's in feet. So our friend's about 4.29 feet. Again, that's not a real good answer. If you leave it that way though, I'd probably accept it. But for those of you who want to overachieve a little bit, what you could do with that is, we know it's 4 feet, and then that 0.29, we take it and we multiply it by 12 because there's 12 inches in a foot. So if we just take 0.29 times 12 on our calculator, we come out with 3.48. Well, what we've done when we multiply that by 12 is we've converted this 0.29 feet into inches. So we got about 3.48 inches, and I would probably round that off to about 3.5 inches. So her friend is about 4 feet, 3.5 inches tall. I would accept this answer, I would accept this answer, I would accept this answer. Any of those three are fine, but this is probably the best answer because it makes the most mathematical sense when you're dealing with feet and inches. Number 3, Juanita, who is 1.82 meters tall. And you see when we start dealing with meters, it's got decimals in it, so that's why the metric system's better. Wants to find the height of a tree in her backyard. So we got Juanita here. She's 1.82 meters tall. And she's trying to find the height of some tree. Or that stray mark there. Sorry, I'm drawing this wrong. Should read the whole problem. It says, from the tree's base, she walks 12.2 meters along the tree's shadow until her head is in position where the tip of her shadow exactly overlaps the end of the tree's shadow. So they're saying that you got the tree here, and it has a shadow, and Juanita walks on that shadow and lines up the end of her shadow with the tree shadow down here. So this is the second shadow method. We've got our triangle going down, our two triangles going down through here. We're still going to match it up the same. They tell us that she's 1.82 meters. And she walked from the base of the tree to where she's at, she walked 12.20 meters. She is now 6.1 meters from the end of the shadows. So from here to here is 6.1 meters. And they want to know how tall is the tree. If I separate this off, and I'm going to separate it off because I can't understand it this way. I got the tree's triangle. I got Juanita's triangle. I know in Juanita's triangle this is 1.82. This distance is 6.1. For the tree, this is the height of the tree. We don't know. That's X. And then we need this whole distance, the tree's whole shadow here. So what we got to do here is we got to take that 12.20 and we got to add on the 6.1. And that comes out to be 18.3. So the length of the whole tree shadow is 18.3. Then we set up our proportion. Juanita's height, 1.82. Matches up, and I'm going backwards this time, just put Juanita first, it doesn't matter. Matches up to the tree's height, which is X. And then Juanita's shadow matches up to the tree's shadow, so 6.1 matches up to 18.3. Cross multiply, you grab your calculator, 1.82 times 18.3, and we end up with about 33.3. That's close enough. It goes out a little farther than that, but you can round it off that way. We do it this way. That's 6.1 times X. We divide. These cancel out. You're left with X equals, and we take 33.3 divided by 6.1 on our calculator, and I come out with something about 5.46. We round it up a little bit. Usually the way you decide how to round is by looking at the problem. Most of the numbers in the problem went out 2 spaces. So we probably want to go, when we round off our answer, we probably want to go out 2 spaces. So that tells us that the tree is about 5.46 meters tall. Make sure that your answer makes sense. If you're coming up with a tree that's something like 3,760 meters tall, it's probably not going to make much sense because there's no trees in the world that are that tall. 5.46, if you're not sure about the metric system, if you're not sure about meters, just know each meter is about 3 feet. So if we take this and we multiply by 3, 5 times 3, we get that that's about 15. Well, it makes sense for a tree to be 15 or so feet tall. It's a little more than that. It'd be probably closer to like 18, 19, somewhere in there because of the 0.46. But that gives you an idea about how tall it is. Number 4 says, and I know that pictures are hard to see on these, similar triangles can also be used to find the distance that are difficult to measure directly. Calculate, that's why it's called indirect measurement. Calculate the distance across the canyon shown at the right by sighting a rock on the opposite side at point R. Select points G and D so that segment GD is perpendicular to RG. Next, measure a convenient distance ND with ND perpendicular to DG. Then locate point A, the intersection of segment RN and segment GD, because angle D and angle G, those are supposed to be angle symbols there. The computer didn't like them for whatever reason. Are congruent, and angle DAN and angle GAR are congruent, then triangle DAN is similar to triangle GAR. The distance across the canyon can be determined because the triangles are similar. If GA is 120 meters, DA is 60 meters, and ND is 50 meters, find GR, which is the distance across the canyon. And that sounds like a whole lot, but it's not as hard as it seems. So I have the picture drawn here. If you can't see the picture very well, I know it's dark, but then let's go back, and it says GD, that's this segment going across through here, is perpendicular to RG, which is right here, so that they're telling us that that should be a right angle. My picture's not drawn the greatest. And ND is perpendicular to DG. So and again, my picture's drawn horribly. So this right here should be a right angle. And then they tell us that angle D and angle G are congruent. Angle D and angle G are congruent. That's because they're right angles, so they're both congruent. And angle DAN, that's this angle, is congruent to this. I'm not sure why they had to tell us all this, because we know that these two are congruent because they're both right angles, and we know these two are congruent because they're vertical. And then that tells us that these two triangles are similar because of angle. Let's jump down to, it says segment GA. That's right here is 120. Segment DA is 60. So that's right here, that's 60. Segment ND is 50. Segment, and they want us to find segment GR. That's right here, so I'm going to put an X right there. With this, we're just going to use the similar triangles and match them up and set up our proportions. It's not really a shadow problem or anything this time, it's just matching them up. Make sure you realize that to get this triangle to match up to this one, you're going to sort of have to spin it around, rotate it around. And if I do that, the 120 over here and the 60 are going to match up. So I'm going to match up, I'm going to start with this side, and I'm going to go 60, matches up to 120. So the 60 matches up to 120 because it's going to rotate all the way around to here. The same as the 50 matches up to the X. If we can cross multiply and we can solve here, and we could do 60 times X and then 120 times 50. If you grab your calculator and do 120 times 50, and I get 6,000. Ignore that. But if you look at this and you see that, hey, this 60 is half as much as that 120, then it's got to be the same way over here. That the 50 has to be half as much as whatever's on the bottom, or the bottom has to be double whatever the top is. So if I'm looking at that, and I could go ahead and solve the proportion and everything, but if I'm looking at it that way and I can do that without a whole lot of trouble, then use it and don't do all the math work. So 60 over 120 is going to be the same as 50 over, if we double that 50 to get this bottom number, well then that means it's got to be 100. And that was in meters. So the distance across the canyon would be 100 meters. All right, on number 5, it says, on an overcast day, Private Eye Samantha Diamond needed to calculate the height of a window in the nearby building. So I've got this picture drawn. Because there were no shadows, she used a mirror. So this is our mirror right here. And she set up the mirror so that when she looked into it, she could just see, and she was standing upright, she could just see into the window that she wanted to see, she wanted to look at in the building. So we have our two triangles there, and again, these two triangles are going to be similar because of angle. Then it says the mirror was 1.22 meters from her feet, so this is 1.22 meters, and 7.32 meters from the building. My pictures aren't drawn to scale, just know that you just have to draw them and match them up. Don't make them more difficult than they are. Doesn't have to be any special kind of drawing. And they tell us that Sam's eyes, where she's looking down here, is 1.82 meters off the ground. We want to figure out this height right here, so that's going to be our X, and we're just going to set up our proportion. It's going to be Sam's height, 1.82, compared to the height of the window, which we don't know what it is, so that's our X. So this height compared to this height, and then Sam's distance from the mirror compared to the building's distance from the mirror. So 1.22 on top here, 7.32 on bottom. We grab our calculator, we cross multiply, we get this way. If you like to, when you cross multiply, if you always like the X to be on the left hand side, then do the part with the X in it first. It makes no difference. So if I do 1.82 times 7.32, I end up with 13.3224. And if you're getting smart at these, you can leave that number in your calculator because you're going to use it again here in a minute. And we do this way, and we get 1.22 times X. We are going to divide by 1.22. We already have this number in our calculator if you didn't erase it. So all you got to do is hit divided by 1.22. And I end up with, these cancel out, end up with X over there. And on the other side, I end up with 10.92. So the window is 10.92 meters off the ground. All right, on problem 6, it says late one afternoon, it's like I'm reading you a bedtime story. While being chased by the sheriff of Nottingham into an unfamiliar part of Sherwood Forest, Robin Hood and Little John found themselves trapped between a wide chasm. If you don't know, a wide chasm is just a deep ditch like and the approaching sheriff. A bridge had once spanned the chasm, but was now collapsed. Fortunately, the bridge's sign was still standing. That's how I got the sign right here. It gave Robin Hood the information necessary to plan his escape. The chasm was 36 feet across, so the sign tells him that the distance across here is 36 feet. A large tree grew near the chasm, the only tree within 50 yards. So there wasn't any other trees anywhere around. We really don't need that 50 yards. It's just telling you that you can't try to use some other tree. Robin quickly paced off the distance from the cliff edge to the tree. So he paced off this distance from here to here. And he figured out that it was 24 feet. He noticed that the shadow cast by the tree reached directly across the chasm, and the tip of the shadow just reached the opposite edge of the chasm. So the tree's shadow went across here, and it just reached this opposite side over here. Robin hastily measured the shadow created by his 55-inch, this is Robin Hood over here, his 55-inch frame. So that means that Robin Hood is 55 inches tall, and he measured his shadow, and it was 77 inches. Using the information, Robin Hood calculated the height of the tree. What is the height of the tree to the nearest foot? If Robin and Little John chopped down the tree, would it be long enough to reach the across the chasm? Was Robin Hood able to elude the sheriff of Nottingham? So they're asking us 3 questions there. We'll answer them all here in a minute. First thing, with all this drawing, thing that you need to remember, you got Robin's shadow. Ignore that. He's 55 and shadow, or you got Robin's triangle, I mean, he's 55 and shadow 77. Then you got the tree, and you got its shadow. We're trying to find the height of the tree here, so that's going to be our X. The tree's shadow, we come back over here, it's this whole distance. So we got to take the 24 and the 36 and add them together. So 24 plus the 36, and that gives you 60. So the tree's shadow is 60 feet. So now we're just doing a basic shadow problem. This is in feet, this is going to be in feet, this is in inches, that's in inches. It's all right for these as long as everything in this triangle is in inches and everything in this triangle is in feet. It's all right for it to stay that way. We really don't need to change all these. If if you wanted to change, it's probably easiest to change this into inches, but it's gonna give you the same answer regardless. So as long as this whole triangle is in one unit, this whole triangle's all in the same unit, that's all that matters. It doesn't matter that we have different units here than we have over here. So I'm gonna match these up. I'm gonna match up Robin Hood's height, 55, with the tree's height. And then Robin Hood's shadow with the tree's shadow. Again, if you want your X to be on the left every time, then do the cross multiplying that's got the X in it first. So if I do it that way, that's gonna give me 77X. And if I grab my calculator and I do the other direction, I get 55 times 60. And again, it doesn't matter that those are in different units because it's all gonna work out in the end. Once I have that, I divide this by 77, divide this by 77, these cancel out. This leaves me with X equals, you already got the 3,300 on your calculator, you just hit divided by 77, and that gives us 42.857, so on, it just keeps going. They said round off the height of the tree, and that's what this is. Round off the height of the tree to the nearest foot. So we're going to round it off to about 43 feet. The height of the tree is about 43 feet. So that's one of our answers. The second part said if they chop down the tree, would it be long enough to reach across the chasm? So if this tree is 43 feet tall, and they chop it down right here where it's at, is it going to be long enough to reach to the other side of the chasm? Well, from the base of the tree right here to the other side of the chasm is 60 feet, and this is 43 feet, so the answer to that is no. It's not going to reach the other side, unless they could somehow get it closer and drop it right at the edge of the chasm, then yes, it could, but if they just drop the tree right here, when it falls, it's going to end up laying something like that, and it's not going to reach over the chasm. And then the last part of the answer was Robin Hood able to escape. The answer to that part of the question would also be no. All right, on number 7, these are a little easier, not so much reading. Says parallelogram EFGH is similar to parallelogram WXYZ. What you have to remember on these, and I'm just going to write in E right here. The E in the first parallelogram matches up to, if you look at the names, matches up to the W. So those two angles match up. That means we know that those angles are congruent. They're already telling us that they're similar, so we don't have to worry about proving that they're similar. But we just want to make sure that we match up everything right. Well, and we're looking for segment WZ, which is down here at the bottom. And this is segment EH down here. That's what we're looking for. You're just going to set up this proportion and just make sure you match up everything right. This one's pretty easy to match up, just because they've got it set up for you. The 2 is going to match up to the 6. And the 3 is going to match up to the, just making sure we're going the same way each time. 3 matches up to the X. And then we just cross multiply and solve. 2 times X is 2X. On the other side, 6 times 3 is 18. Divide by 2. You end up with X equals 9. They ask us to find the length of segment WZ. But we know that that length then is 9 inches. Number 8 says Lance the alien is 5 feet tall, his shadow is 8 feet long. At the same time of day, a tree's shadow is 32 feet long. what's the height of the tree. So they give you the picture there. I'm not gonna draw the picture because I'm not gonna be able to draw Lance the alien very well anyway. We just know that we're gonna set up a proportion. So you got Lance's height, which is 5 feet, compared to the tree's height. That's the part we don't know, so that's gonna be our X. Lance's shadow, which is 8 feet, compared to the tree's shadow, which is 32. Again, I don't want you trying to do this all the time, but if you're looking at this and you can figure out the scale factor for this 8 to 32 is 1 to 4. If we reduce that 8 over 32 down to 1 to 4, that's the scale factor. That means for every one part on top here, there should be 4 parts on bottom here, and that's pretty easy to do. So we just take this 5 and we multiply it by 4, and you can figure out that X should be 20. If that confused you, then cross multiply. If I cross multiply this way, I get 8X. I cross multiply this way, grab your calculator and you do 5 times 32. Get 160. Divide both sides by 8. You end up with X equals 8 will go into 160 20 times. So either way, if you can figure it out that, you know, without doing all the math and the cross multiplying and everything, and you're getting them right, then go ahead and do that. Shorten up the problem, make it easier on yourself. So our answer here is that the tree is 20 feet tall. Number 9, they give us this picture, and they tell us that Pentagon JKLMN is similar to Pentagon VWXYZ. And you just got to make sure that you're matching them up correctly. These, it's pretty easy to match up because the way they have them drawn looks like they match up just like that. But if I look at L here, if I look at angle L and look at the names that they give us on the paper there, L is the 3rd letter in the first name, then it's got to match up to the 3rd letter in the second name, which is X. So that L is going to match up to the X right here. And you got to remember that in similar polygons, that corresponding angles are congruent, because that's what they're dealing with this time. They're trying to confuse you a little bit and make you set up a proportion. Well, this time we don't need to set up a proportion because corresponding angles are congruent. So if angle L is 60 degrees and it matches up to angle X, then the measure of angle X has to be 60 degrees. And it's that simple. They just have to match up. And if we look at the K here matches up to the W. They didn't ask us to do this, but the K matches up to the W. Then we know angle W over here would have to be 150 degrees. But our answer for this problem is just the 60-degree angle there. Corresponding angles have to be congruent. Sides are proportional, angles are congruent. All right, number 10, they're asking us to use these two triangles, and they're asking us to find this side right here, YX or XY, whichever way you want to name it. We got to, again, make sure that we match up the triangles correctly. This is the way that they named them. So here we know that L has to match up to X, M has to match up to Y, N has to match up to Z. So when we go to set up our proportion, we want to make sure that we're setting it up correctly. Make sure that we're matching things up correctly. So I'm going to just go through here, and I got, if I look at segment LN, that's the first two letters in this name, that's the 18 right here, I'm going to circle it. That has to match up to XY, which is what we're looking for. And then segment MN over here, which is this one, oops, I'm going to put a rectangle around it so I know which ones I'm matching up, is got to match up to the last two letters here, which is YZ. YZ is right here. Well, we don't know what it is, so that doesn't really help us a whole lot. And then that tells us that these other two, the 24, I'm gonna put a little squiggly around it, has to match up to the 8, just to make sure we're matching it up right. So this triangle we have to sort of spin around to get it to match up correctly. So now I'm gonna set up my proportion, and first thing I always look for is I look for the ones that I have numbers for. Well, the squigglies are the ones I have numbers for, so I'm gonna use this 24 and match it up to that 8. So 24 matches up to 8. The same as, then the circles, I'm gonna start here, 18 matches up to our variable, which we don't know, so I'm, instead of using x, because we already have an x here, I'm gonna use some different variable. I'm gonna use a little a. Doesn't matter what the variable is. We cross multiply, get 24a equals, cross multiply this way. Main thing here is to make sure that you match them up correctly. We cross multiply, and 8 times 18, you grab your calculator, 8 times 18 is 144. Divide both sides by 24. Again, you already got the 144 in your calculator there if you used it. So you just hit divided by 24, and you end up with 6. So that tells us that this missing part right here is 6 feet long. This one, if we look at the names on number 11, it says triangle, ignore that triangle, triangle PQR is similar to triangle DEF, just making sure that we can match it up correctly. So PQ, right here, if we look over here, PQ, that's the first 2 letters, should match up to DF, which is right here. So in our first ratio, it's going to be 4. Matches up to 6. It looks like this one we don't have to spin or anything, so it looks like it's in this correct order. And then the 6 is going to match up to 9. Should read the whole problem, I guess. It says, which describes the relationship between the corresponding sides of the 2 triangles. All right, so PQ, let's forget this for a second. If we look at PQ, it matches up to segment DE, and that was 4 matches up to 6. Well, if we look down there, we know that PQ matches up to DE, and if that's one of our answers down there, which it is, that's letter A. So our answer for this problem, since it was multiple choice, is just A. If we look at the others, B says PQ matches up to DE, so that part's right. But then it says 6 to 4. They did that backwards. And then C says PQ matches up to EF. Well, those 2 sides don't match up. And then the next one says PR matches up to DE. So PR matches up to DE. Well, that's not the case. PR matches up to DF. So A is the only answer that it could be. Number 12, you got to read the problem and draw your own picture. A 6-foot tall person is standing next to a flagpole. The person is casting a shadow that's 1.5 feet in length, while the flagpole is casting a shadow 5 feet in length. How tall is the flagpole? So I got a person. person here, and they are 6 feet tall, so we'll put 6 feet there. They got a shadow, and it says that that shadow is 1.5 feet long. And then the flagpole, and it's casting a shadow that's 5 feet long. And we're trying to find the height of the flagpole. Well, we're just gonna match them up. Person's height, 6 feet. Flagpole's height is X. 6 matches up to X. Same as the person's shadow, 1.5 feet. With 1.5 feet, that's 1 foot 6 inches. But we probably don't want to change it to that, and we don't want to change it all into inches, because then that's going to mess up stuff, because we need to change this into inches. So probably with 1.5, you could just change it to 1.5, and that's going to be all right in this case. And it matches up to 5 feet. We cross multiply. Again, if you want the X to be on the left, you want to multiply these first. So 1.5 times X equals, multiply this way, 6 times 5 is 30. Divide both sides by 1.5, grab your calculator and divide 30 by 1.5. And you end up with 20. Make sure your answer makes sense. You're saying that the flagpole is 20 feet tall. Well, that makes sense for a flagpole to be about 20 feet tall. This time they tell us that these two triangles are similar to each other, and they've got the markings on them here to show us that they're similar by angle, and we can use those to match up the two triangles. They want us to find the perimeter of this triangle. We could go through and we could find the length of this side, and then find the length of this side, then add up all 3 sides to find the perimeter. But we had that theorem, so the easier way to find the perimeter is we can figure out this perimeter over here just by adding up all the sides, because we know all them, and it comes out to be 21. And remember, the theorem said take a side from shape 1, compare it to a side from shape 2, and that's going to equal the perimeter from shape 1 over the perimeter from shape 2. So we're just going to set that up. So we just have to make sure that we match up sides. So looking at side in the first triangle here, well, if we look at the 10, it would match up to this bottom side that we don't know. If we look at the 6, it's going to match up to this side and we don't know it. But if we look at the 5, it matches up to the 30. So that's probably the ones that we want to pick. 5 compares to 30. And then we want the perimeter of the first shape, which is 21, compares to the perimeter of the second shape, which I'm just going to leave as P because we don't know it. Then we cross multiply, you end up with 5P equals, you cross multiply this way, grab your calculator and take 30 times 21. You end up with 630. And then we want to get P by itself, so we divide both sides by 5. And you end up with P, that's a P equals the perimeter of the second shape. Just divide 630 by 5. You end up with 126. Did they give us any units on this one? Doesn't look like it. So the perimeter is just 126 units. Number 14, they tell us that, and they give you a picture over there you can see, And I got the tree. I'm just gonna draw the two triangles. I'm not gonna draw the tree. This is 1 foot. This is 8 inches, so 1 foot. We take a ruler outside and we set it down and cast an 8-inch shadow. And the tree that we're trying to measure casts a 24-foot shadow. And they want us to figure out what's the height in feet of the tree. Well, since we got inches and feet over here, what you need, we gotta have all the same units in each triangle, so probably what we wanna do is change this 1 foot into 12 inches. So we're gonna get rid of that, and then we're just gonna set up our proportion using that. We're trying to find this, which is X, the height of the tree, and we're just gonna match them up. Again, it doesn't matter that all of these are in inches, or all of them are in feet. What matters is that everything in this triangle is in 1 unit, everything in this triangle is in 1 unit. So if we match these up, the 12 inches here matches up to the X, the height of the ruler matches up to the height of the tree, the shadow of the ruler matches up to the shadow of the tree. Cross multiply, and that gives us 8 times X. Cross multiply this way, 12 times 24. And we get 288. Divide both sides by 8. And we end up with 36. That 36 goes here. Since this was in feet, that means that answer's in feet, so it's telling us that the tree is 36 feet tall. Again, make sure that your answer makes sense. Yeah, it makes sense for a tree to be 36 feet tall. That's not way too tall or way too short. If you wanted here, something I should say, if you wanted to on this, instead of changing this into feet, you could have changed this inches, or I'm sorry, instead of changing this into inches, we could have changed these inches into feet. And the way you do that is just by putting 8 over 12 and then reducing that down. 4 will go into 8 twice, 4 will go into 12 3 times. So we could have used that fraction, 2/3 of a foot, in place of that, and we'd set up this proportion. And set up, this is 1 foot. Now if we're going back to where all this is in feet, so we got 1 foot compares to the height of the tree, which is X, and then 2/3 compares to the 24. So if that makes it more sense to you, because now everything is in feet, then do it that way, and when we cross multiply, we get 2/3 times X equals 24. And then you're just going to divide by 2/3, but if you remember back to your middle school days, when you're dividing by a fraction like 2/3, that's the same as multiplying by the reciprocal, which is 3/2. Remember back to your algebra days. So you're multiplying by 3 over 2. These cancel out. You're left with X. And if you take your calculator, all you're going to do here is you're going to multiply 24 times 3, and then you're going to divide that answer by 2, and it's going to end up giving you 36. But the main thing here is know that 8 inches is 2/3 of a foot. So if I had 4 inches, that'd be 4 out of 12, which is 1/3 of a foot. If I had 6 inches, that's 6 out of 12, which is 1/2 a foot. If I have 5 inches, that's 5 out of 12, which is 5/12 of a foot. That won't reduce any, and you could just use that. But that's something else to remember. All right, on problem 15, they give us a picture. It looks like this, and they tell us these two triangles, ADE, is similar to triangle ABC. First thing I would do with a picture like this is I would separate the two triangles. So if I take the big triangle, that's or the small triangle, which is right here, that's triangle ADE. Separate it off. there, A there, E there. And this is X, this is 3, this is 2. And they're telling us it's similar to the big triangle, which is this triangle, ABC. Now what you got to be careful of in the big triangle is this side over here, that's this whole thing. Well, we know this part's 3, but we don't know this part, so we don't know this side in the big triangle. We know this side over here is 12. This side, well, we know this part's 2 and this part's 4. So to get that whole side there, we just add those two together, and 2 plus 4 is 6, so that 6 goes there. And then you got to make sure when you set up your proportion, you match them up correctly. I look here, the 3 is here. Well, it would match up to this side, but we don't know that side, so that's not really going to help us. The 2 matches up to the 6, so that does help us. So we can go 2 matches up to 6, the same as X matches up to 12. Again, this has got pretty easy numbers in it, so if you could come up with the answer on your own without doing the cross multiplying and everything, then do it. But here, if I cross multiply, I get 6 times X. I cross multiply this way, 2 times 12 is 24. Ignore that. Divide both sides by 6. And I end up with X equals 24 divided by 6 is 4. So I end up with X equals 4. Go back and make sure your answer makes sense. Does it make sense for the length of that side in that triangle to be 4? Yeah, that seems to be sensible. All right, I'm going to stop there for this video. I know that was a little longer than I want it to be. I'm going to make a second video finishing out the rest of this worksheet, but for now, use that and try to do some of the others on your own. Again, all I really want is you to send me 2 pages of, and I'll explain this in the directions, 2 pages, just a picture of 2 pages that you worked out on this packet. You don't have to send me every page. So you can watch the second video and try to get you, give you some extra help with the others, making sure that you got them right. And the next assignment is going to be the test over similar triangles and solving the proportions and everything.